So firstly, what is eFactory? Okay, eFactory is Mitsubishi Electric's total FAIT solution that uses edge computing to link FA to IT domains, okay, and help you to build your system easily, okay, and support your customers' continuous improvement, okay, to reduce total cost of manufacturing. Okay, as you can see on the right-hand side, okay, this is the eFactory architecture. Okay, so we have the edge computing area to link the FA to IT layer. Okay, and eFactory has been started in 2003. Okay, so from this eFactory architecture, firstly, for visualization, we will do data collection in real time from the shop floor area. Okay, at the edge computing layer, this is where we do real-time data processing, okay, and pass this information to the IT layer for further analysis if needed. Okay, and in terms of improvement or optimization, we can immediately feedback the result of the analysis from the edge computing layer to the shop floor layer. Okay, so we can have immediate feedback to the shop floor layer or even from your IT system layer. Okay, and what are the advantages of eFactory? The eFactory helps you to increase your productivity. So you will have reduction in the parts rejection rate. Okay, and in terms of quality, will help you improve your quality production. And in terms of sustainability, you can see like avoiding waste, like energy saving. Okay, in terms of safety, will help you have a safe environment for your people to work in. And lastly, security, okay, to enhance cyber security to protect all your equipment. Okay, next let's look at the core products and technology that help support eFactory. Okay, as we mentioned that the FAIT linkage is a technology represented by edge computing layer. So at this layer, we have products like mesh interface module, which allows you to directly connect to the database, C controller CPU. We also have Mitsubishi Industrial PC now with real-time data analysis functions, okay, to provide primary processing and feedback to your shop floor in real-time basis. Okay, and this edge computing layer also goes down to your control technology area to collect and control the necessary data from your robot technology and production sites. Okay, and we also have our CC-Link IE-TSN network, okay, which is TSN stands for time-sensitive network, okay, which realize large volume and high-speed communication in sites, okay, where you can have different networks being mixed on the same cable. Okay, like example, you can have OPC, OPC-UA, TCP/IP, and CC-Link IE-TSN running on the same cable. Okay. And as we know, right, there are some barriers on our production floors. Barriers like network separation, system partitioning, and different data division. Okay, these three segmentations are actually some barriers to our shop floor in preventing digital transformation. Okay, however, for Mitsubishi, in order to accelerate this collaboration and innovation, okay, we have open alliance, open network, and open platform. Okay, so with eFactory concept in 2003, we have eFactory Alliance in 2011, where we have partners to help us realize the eFactory solution. Okay, and in 2017, announcement of our open platform, HCross Open Software Platform, okay, where Mitsubishi is one of the board members. Okay, this organization is to reduce the problems on production line with multiple vendors, diversity of equipment, and differences in network standards. Okay, and above HCross, you will see that we have this term called MISAT. Okay, MISAT is Mitsubishi Artificial Intelligence State-of-the-Art Technology. It is our very own R&D solution, okay, where we have a group of data scientists in Japan working on AI technology. Okay, and in 2018, okay, we launched CC-Link IE-TSN, okay, which is a very first open network running at 1 gigabits per second. Okay, so talking about eFactory Alliance, okay, this is actually because Mitsubishi is an automation supplier, so work with to collaborate to provide the most optimal and appropriate eFactory architecture as a solution. We are working with device partners at the shop floor layer, SI partners on the edge computing layer, and software partners on the IT layer. Okay, as of now, we have more than 700 companies globally as eFactory Alliance partners. And the number of systems being installed worldwide is about more than 10,000 systems. Okay, these industries include automotive, semiconductor, electronics, F&B, and metal, etc. Okay, and in Singapore, we also have our own eFactory Alliance partners. Okay, where we started this inauguration ceremony in April 2018 last year. Okay, and also eFactory solution has gained a strong reputation in the global market as well. As you can see over here, we have the ARC Research Group, okay, where they released a new white paper to mention about how eFactory is very suitable for adoption of smart factory manufacturing technologies. And also Frost and Sullivan in 2015, recognizing Mitsubishi Electric's eFactory concept with an IIoT Innovation Awards. Okay, so from here we can see that eFactory will help you on your solutions and also IoT solutions, and you will see that IoT actually brings a lot of benefits to you. Okay, however, with all these benefits, you might see that there are also some problems when you want to start applying IIoT to your manufacturing industries. Okay, so what are some of these problems that you see? Like example, maybe your management asks you, can you please go and start IIoT? So you might have some questions like, how do I can collect this data, but how do I analyze them? Okay, and I also don't have the time to study these new analysis methods. Okay, and maybe at this time constructing a system is hard, and I have limited budget. And I want to start on something that is easy and low cost. Okay, and sometimes you might receive a top-down instruction, okay, to consider IoT, but I might scratch my mind like, where do I get started? How do I actually get started? Okay, and also most of us are occupied with your current job. Okay, so it might be difficult to consider IIoT in parallel with your current existing job scope. Okay, so we can see that there's a need for IIoT solutions at manufacturing sites, okay, whereby you want to leverage on your existing manufacturing assets and bring IIoT benefits at a low cost and in a short time. Okay, in the next few slides, I'll answer these questions on how do I actually get IIoT benefits at low cost and in a short time. Okay, firstly, I would like to share with you this Smart Manufacturing Kaizen Level, or SMKL. Okay, this is what Mitsubishi has come up with this strategic planning tool. Okay, this is built from our experience of implementing smart manufacturing at our own factories. Okay, this is actually to help you plan and execute your smart manufacturing solutions. Okay, Kaizen level refers to the level of impact or effectiveness on the enterprise. Okay, we actually also have a white paper with ARC Advisory Group on this SMKL. So if you're interested later, you can get in touch with us. Okay. So on the screen here, you can see that using SMKL as a strategic planning tool. So on the bottom, the x-axis will be the degree of penetration. Okay, where level 1 will be the smallest cell, like individual worker or small installation. Level 2 will be the workshop level. Level 3 will be the factory level. Level 4 will be the supply chain. Okay, and the y-axis, you will see the degree of effectiveness. Level A will be collecting of data. Level B, visualization. Level C, analyzing. And level D, optimization. So from this chart, it's very clear that everything needs to start from data collection, okay, before you can proceed on to any visualization, analysis, and optimization. Okay, and you can see here from this flow, it can actually help you to plan your IIoT roadmap also. Okay, like maybe you want to start, for example, if you want to do a production improvement trajectories. Okay, we can start the worker lab and slowly build up from collecting data to visualization, analyzing, optimizing. Once we are done with this single cell level, we can move on to the workshop level, which is 2D, and automation up to your factory level, which is 3D. Okay. So this tool also help you to look at your risk-benefit analysis of your availability resource to help you decide which path will be most favorable and contain less risk. And I think the most important to all of us is to review our ROI before scaling up. Okay, and at the bottom of the screen here, okay, I'm showing the SMKL to show you to how to map technologies and plan your competence development. Okay, where this tool also helps you to understand besides equipment and people, okay, which need to start producing electronically accessible data, you also need to have some certain knowledge. Okay, you might want to invest in the training of your people for you to move into different degree of effectiveness. Okay, for example, we look at project A when you're doing condition monitoring. Okay, so you need at level 1A, 2A, you need to have network capability, and level A to D, you need to have AI knowledge, and at level D, you need to have edge computing knowledge. Okay, another example would be line control, project B. So we have at the level 1A, you need to have some sensor network knowledge. Before moving on to the next visualization and analysis level, you can build on controller, HMI solutions, and engineering tools knowledge. Okay, so in summary, this tool actually supports your collaborative project resources and investment planning, okay, at strategic level as well as operational level. Okay, so example for today, we are talking about the topic of how to start IIoT. Okay, so I will take this example here, level 1A. So this is the place where you want to start at a single cell level to move on from collecting data, visualization, and analysis. Okay, this is where today I want to talk to you about our eFactory starter package. Okay, this is a sample project, okay, which is targeted at the shop floor level, okay, which is similar to just now the SMKL level, which I told you we start at a single cell level, 1A to do collection, 1B to do data analysis, then visualization and analysis. So this package will provide the various functions to realize your IIoT, okay, visualization and simple analysis at your production site level. Okay. So what is the basic configuration in this starter package? Okay, in this configuration, today I'm talking about the sample project that is available for our IQR series PLC and GOT 2000 series HMI. So in this package, you will see three components, okay, providing you visualization and simple analysis function. So you have the GXWorks3 format sample project for your IQR PLC, GTWorks format sample project for your GOT 2000, and a manual. This manual is to teach you how to set up the functions to do your OEE functions. Okay, so what are the benefits of using this eFactory starter package? Okay, the first benefit that you will see is low cost installation. Okay, because you don't need to create the sequence program and screen data from scratch just to do your visualization or analysis. So everything is done for you in the template. You just need to download the project into the PLC and HMI, okay, connect to your machine, and you can get IIoT started. Okay, so inside here, you will see functions that focus on management, maintenance, and improvement of your equipment. Okay, the next advantage is easy IIoT application of equipment. So you just need some basic settings like device assignment and parameter setting. Okay, device assignment meaning that you connect your I/O signals to the PLC, okay, to get all the required signals in for processing. Then you can have a clear graphic display of analysis results on your GOT 2000. Okay, if you want remote monitoring, you can even do this monitoring on soft GOT 2000. Okay, so how do you actually use this package, okay, for your site? So you can start on two ways. One way is you're actually planning for new equipment, and at the same time you want to incorporate this eFactory starter package IIoT solution to your project at the same time. Okay, so you start afresh with by just immediately getting a IQR PLC GOT 2000, okay, with a eFactory starter package. Or the other way is you already have some existing equipment at your site, okay, and you want to add on this IIoT, okay, to provide visualization and simple analysis. So this way you prepare a new set of IQR PLC and HMI, connect to your existing machine. Okay, so in this way you won't affect the operation of the existing equipment, okay, and you don't need to develop another IIoT program. Okay, and if you're connecting via Ethernet, okay, our Mitsubishi PLC can also collect data not only from Mitsubishi PLC, okay, you can also collect from other vendors. So you can also do analysis from other vendors' PLC. Okay. So what is this package offering? So we are offering this package, the function called multiple function called Equipment Operation Monitoring Solution, or OEE. Okay, inside this package, there are about 10 functions together. Okay, so I'll explain to you the 10 functions in the next few slides. So the main functions is management, improvement, and maintenance. Okay, so over here you will see these different functions that I mentioned. So for management function wise, okay, you will see a dashboard, okay, which displays your production and operational status of your equipment, like your OEE, how many products are being made. And at the same time, you can see some status of the alarm on this screen. Okay, so these are all the template screen that you will get if you use the eFactory starter package. Okay, and next you have this production count screen, okay, which helps you visualize the production information like the number of production, number of non-defective products, history of the product type that you have made, okay, and can view them in time zone and lab. It is. Then you also have an operational status monitor. Okay, this will help you visualize the status of your equipment. Like, how is my equipment doing now? Is it operating, stop, or having some non-operating conditions, okay, over the time? Okay, this is being monitored in real time. Okay, and under maintenance function, we have cylinder and cycle time monitor. Okay, these functions are help you to do detection of anomalies in equipment, okay, and giving some management of measures. Okay, so for cylinder and cycle time monitor, it helps you to measure the operating cycle of your cylinder and equipment, so you can properly plan for maintenance. Okay, so it can be used for predictive maintenance and abnormality detection. Okay, and for error sign or error sign meaning just a simple warning or alarm signals. Error stop will be critical error or stop signal. Okay, this one will allow you to have some troubleshooting guidance, the history of when these errors happen. Okay, and you also register the detail of measure. Okay, how you address to these alarm or warning signs. Okay. So under improvement function, these functions allow you to analyze your process control and points of production equipment to be improved. Okay, firstly, you look at the Pareto chart. Okay, this chart actually visualizes to you the top 10 errors of your equipment problem. Okay, so from here, you can straight away visualize what is the main problem that is causing your machine to stop. So you can do some planning to make sure that this problem do not happen again. Okay, and we also have the X bar R chart. Okay, this enable you to do real-time monitoring on how stable of your production process is. Okay, where you can do immediate improvement by just visually checking these variations in quality. Okay, when you monitor your X bar R chart. And lastly, we have the loss time analysis. The loss time analysis can be used to analyze your 16 non-major losses. Okay, and also telling you what are the 7 major losses that reduce your production efficiency. Okay, 7 major losses can be your classified into stop loss. It can be a failure loss, setup chain loss, tool loss, and for performance loss, okay, you might be a short stop loss or a low speed loss. Okay, or defect loss, meaning you have a defect or you have a repairing loss. Other loss will be like you have a planned stop and or inspection schedule. Okay, so later on in the demo, right, I'll go through with you all these functions to share with you how all this can help in your first step in IIoT. Okay, so this is actually my last slide on the presentation. So what I would like to talk is about the vision of future monozukuri, or the art of manufacturing. So as you can see, the facilities of the future, okay, at the shop floor layer will be highly AGV robots with self-decision making with AI, okay, and a lot of wireless, and most likely it will be 5G network deployment, okay, due to the wide broadband, low latency, massive data transfer features. Okay, all this will be required for your real-time monitoring, like remote maintenance where you have AR, VR, 4K, 5K images or videos that you will need for troubleshooting or remote monitoring. Okay, so basically you will see the e-collaboration of human, machines, and IT. Okay, and you can see that our e-factory architecture sits nicely over here to support the future monozukuri. Okay, we have open network, CC-Link AI TSN, okay, open platform, H-Cross, open software platform, and IT layer, the e-factory alliance. Okay, so with our e-factory solution and e-factory partnership, we will be able to meet your needs of various departments from value chain up to supply chain, okay, to handle your flexible automation. Okay, where changes to the market demand will help you link to your production sites. Okay, so with this, I would like to move on to the next sharing section, which is I'll give you a demo on the eFactory starter package now. Hold on, please, while I change the presentation. Okay. So before I start, just to check, can everyone see my screen now?
Yes.
Okay. So this is the very first menu page that you will see on the eFactory starter package. So you have the dashboard, okay, the management functions which I shared with you earlier, the maintenance functions, as well as the improvement functions. And you can do a language change, okay, either in Japanese, English, or Chinese. Okay. So this is what you see when you connect your machine to our eFactory starter package solution. So at this dashboard screen, firstly, straight away you can see your OEE of your equipment. So you can see that now my OEE is just 70%, okay, not operating optimally. Okay, and on the right side, okay, you can see the non-operating functions that cause your machine to have some stop loss. Then at the bottom will show your current production type. Okay, what are you producing now? How many products are being made, and the target number. Okay, and at the bottom of the screen, you will see all the alarm signals. Okay, if there's any alarm at the point now, you'll be flashing red, and clicking on it will bring you straight away to the page to assess the alarm. Okay, so you can see here, like everything is already designed for you. You don't need to start anything from scratch. Okay, let me go to the production count page. Okay. So this eFactory starter package actually allows customers to add in their own production data. Okay, so over here I already preloaded with some production data like the product type that I want to make, the comment, the tag time, and the planned target number. So you can register up to 100 products in this production counting screen. Okay, you can load it in using the SD card in your PLC. Okay, and user can also configure their shift operation timing from here. So there's 24 operation timing that you can set for your operating shift. This can also be loaded in from the SD card in the IQR. So with this data, right, you will see that at this production counting screen, you will see the current plan target number, the number of production made, the efficiency, and the yield rate. Okay, and today's total target. And under here, you will see the production history. Up to 5 production history can be seen. Okay, you can look at the target number, how many is produced, how many non-defective products, and how many defective products. And at the time zone here, okay, you can also look at today's data and the past data, okay, by time zone. And by product type also, okay, by this product number 1, how many have I made? Okay, your production history, your production efficiency, and your yield rate, okay, by time zone or by product type. Okay. Okay, so as you can see here, we are keep making products. Okay, so example here I would like to share is so if I'm going to make a defective product, okay, you'll see my yield rate coming down. Okay, as you see, as I click on the NG product, I make a bad product, my yield rate is coming down. So this is what you will see when you're connecting to your real-time equipment. Okay, the next screen I would like to share with you is the process capability index or histogram. Okay, over here you will get to have a visualization of how your production quality is behaving. Okay, where we have this CPK index, process capability index. Okay, if your index is 1 or lower, 1 meaning that you're going to produce bad products, but when it gets below 1, meaning that you already have quality issue. So straight away you can attend to your production line and see what is happening. Okay. So let me do a simulation. Okay, and we start the real-time monitoring. Okay, so now we are collecting data from the field. Okay, and notice this CPK index, okay, is auto-calculating for you. So this data that I input in is a set of good data. So you'll see your CPK index will be 1 or higher, meaning that you're producing good quality products. So imagine without this, you have to manually collect the data from the field, then offline key in into PC just to generate all these histogram. So you can see from here how much work you can save. Okay, and also sometimes human writing down the data, we might have some mistakes. Okay. Okay, so you can see that you are constantly producing good quality data. So let me do a simulation to input bad data now. Okay, so I have changed the data to have bad data. So now you see your CPK index is coming to be below 1. Okay, so straight away I can look at my production, like, what is happening? Why do I have why am I producing bad products now? Okay. And over here, you will see this tool here. This is for you to do some manual settings. Okay, like you want to change your upper limit, lower limit. Okay, it can be changed and the number of classes. Okay. So it's still customizable for you. Okay, let me go to the operational status monitor now. Okay, right now we are monitoring real time your equipment. Okay, you can see that green color means it's operational, yellow color is stop, red color is non-operation. Okay, so on top is a 24-hour operational status monitor, and below is every 1 second. Okay, you can change it to other value that you want to monitor. Okay, every 5 seconds. So let me do a simulation to stop the machine now. Okay, so you can see once I stop the machine, the current status is immediately reflected on the screen. Okay, so you can see at one glance, or is my machine running or stop or having some non-operating conditions. Okay, so this, if you see a non-operating condition, you'll be red color. Okay, let me go back to operation. Okay. So we have looked through the management functions. Okay, now let's look at maintenance. Okay, I'll go to warning inspection first. Okay, this is the area where you see some alarm warnings on your equipment. Let's simulate a warning. Okay, let's say we have error warning number 1, number 2 happening, and at the same time, let me trigger some error stop signal, which is critical errors. Okay, I'll trigger number 1 and number 3. Okay, so we triggered number 1 and number 2 for error warning. So straight away, I can click on the alarm name to address this alarm. Okay, we'll have some action detail like what to do and who is the responsible person that we should connect to on this issue. Okay, then I will start acknowledging this. Okay, I'm the operator and I start acknowledging this action that I have done something. Okay, while performing my action, I finish my attending to this issue. I do an action complete. Okay, then I do the feedback. Okay, I did some inspection on this. I'm operator number 1. I can have some comments. And after that, I just click yes to complete the registration. And you will have this alarm history acknowledgement, okay, registration. So you can see you also have some traceability. Okay, when this alarm happened, who actually attended to it, and what time was it completed, and what did I do? Okay. Okay, you can even schedule the date to attend to it. Okay, maybe I don't want to attend to it now. I want to attend to it next few days. Okay, then you'll see that on 25th, I'm supposed to attend to this. Okay, so this is about error warning. Okay, let's look at error stop. Okay, error stop. So just now we trigger error number 1 and error number 3. So similarly, you can attend to these critical errors. Okay, they also have some advice here which you can customize on your own. Okay, similarly, you attend to this action, do the feedback. Okay. Okay, let me complete the other one also. Okay, so we are done. So with this error stop, right, I would like to bring you to this improvement function where we call the Pareto chart. Okay, so remember we triggered error 1 and error 3 today. Okay, so this screen actually tell you the top 10 equipment problem that you face. Okay, so error alarm number 1 happened 2 times today. Okay, and alarm 2 1 time and alarm 3 1 time, which I triggered today. Okay, and here you can see the graph showing the percentage of percentage rate triggered by each alarm. Okay, and below we can see a 7-day count. Okay, during this 7 day, which are the alarms that are being triggered, how many times? Then you have the waiting time. Waiting time means when the alarm happened, how long did we go to attend to it? And how long did we take to recover the alarm? All this can be captured. Okay, then we have the total count for your top 10 equipment problems. and also the history. Okay, history for the last 7 days and total alarm for the last 7 days. Okay, all this can be captured. Okay, next let's look at the control or X bar chart. Okay, so this one allows you to monitor your mean values and your minimum maximum values. This is more for like small fluctuating monitoring, like maybe your analog values. Okay, like maybe temperature, okay, which doesn't fluctuate a lot. Okay, let me input some data to test. Okay, so we will see that it's currently collecting data. Okay, then over here, the graph, you can see your center line, your 1 sigma, 2 sigma, upper control limit and lower control limit. Okay. Okay, you can also click on the parameter setting to set your own X bar and R value. Okay, so now you see some data is coming in now. Okay, and it's being triggered with alarms. Okay, because on the X bar, we are having an upper control limit alarm. Okay, so under here, you can see that you have various alarms that you can monitor. Okay, the current measured value is shown. Okay, and on the left-hand side, you can see there's a details button. Clicking on it will go into the main detail screen, where you can see the number of times which error is being triggered. How many times is the accumulated times, and which point is the contributing point. Okay, example, alarm number 1, the contributing is this point. Okay. So similarly, like if you were to do manual data collection and you still have to input to PC to get all this, you will need a lot of time. And right here, you see, you just need to collect data and everything is done automatically for you. Okay, and for lost time analysis. Okay, lost time analysis, this is where you monitor your 16 non-operating conditions. Okay, so similarly, you can monitor it in real time in every 10 minutes. Okay, I can also do some simulation here to trigger some non-operating condition. So we have 16 of them. So let's say I trigger non-operating condition number 4. Okay, you'll see that it's running to simulate that there's this error happening. Okay, and it's about how many percent of your total operational cycle. Okay, so also at one glance here, you can see what are the top contributing non-operating conditions. Okay, so this is what we have for the improvement functions. So for the last function that I'd like to share is about cylinder monitoring. Okay, cylinder and cycle time. Okay, why do we need this? Okay, I have a question like, do you have any cylinder or equipment ever run out of cycle time? Okay, and do you actually notice when your cylinder movement is getting slow? Okay, then we should actually reduce your productivity. Okay, and do you actually need a system to immediately detect abnormal cycle time of your equipment? Okay, and how do you actually compare your production efficiency if your cylinder that you use made from different manufacturers with different specs? Okay, so this is the solution for you. Okay, the cylinder and cycle time monitoring function. Okay, so over here we are showing the operation monitoring screen. Okay, where you can see every cylinder. Okay, the forward and reverse action, the measured value, and you have some threshold. Okay, you have level 1 as a warning, level 2 as the limit. So once it reaches level 2, you will trigger an alarm. Okay, master time is the time that you register during your collection time as a reference. Then you also have the accumulated time and the accumulated count for your cylinder or equipment operation. So all these can be monitored. And if your status is showing red, meaning that the forward status is now having an alarm. Green color means okay. So for this screen, you can configure up to 500 cylinders. Okay. Then you can view it in trend graph. Okay, the past 30 operation cycles can be shown here. Okay, where your forward, reverse, the standard deviation of your measured waveform can be shown. Okay, you can change to view other cylinder. Okay, from here also. Okay, at the same time, you can see the alarm blinking, meaning there's some alarms happening. Similarly, you can have alarm history. Okay, what are the accumulated alarms? Okay, you can do by some sorting. Okay, by most alarms and least alarm. Okay, this is the basic setting page where you configure your monitoring screen. Okay, like you want to enable which cylinder. Okay, then when you click on collection start, okay, you will start collecting information on the ground to use them as reference data, okay, for your threshold setting limit. Okay, you can also set a delay timer. Okay, and this sensor position is where you set. Okay, for cylinder wise, we might have sensors at both ends, or sensor at either end, or we might even have no sensor. Okay, no sensor will depend on the cycle time. So all this setting can be done. Okay, and you also see that there's this number of intermediate position sensor. Okay, meaning because some cylinder you might have some intermediate sensor between both ends. So you can also monitor up to 16 intermediate sensors. Okay, all this can be configured. Okay, so these are the standard deviation and accumulated setting. Okay, and lastly, the monitoring permission setting. This is where you enable which cylinder you want to monitor. Okay, so you can have up to 500 cylinders to monitor for forward as well as reverse action. Yeah, so this is the overview of our eFactory starter package. Okay, so this is how it looks like when you actually connect to your physical machine. Okay, so with that, I'd like to thank you all for your time, and I hope I have give you a very good information on our eFactory solution as well as our eFactory starter package. So I also we will be launching the next webinar. So I'll also be looking forward to your joining us in the next webinar. Okay, thank you.